Hello and welcome back to Advent of Cyber. This is day 11 and it's going to be XSS. Merry XSSMas. So today's going to be about cross-site scripting. Alright, so day 11 reads as, after last year's automation and tech modernization, Santa's workshop got a new makeover. McSkitty has a secure portal where you can contact her directly with any questions or concerns. However, lately the logs have been lighting up with unusual activity ranging from odd messages to specific search terms. Even Santa's letters appear to be scripts or random code. Your mission, should you choose to accept it, dig through the logs, uncover the mischief, and find out who's trying to mess with McSkitty. So the learning objectives for today is going to be understand how XSS works and learn how to prevent XSS attacks. So we're going to go ahead and connect to our machines and start attack box. Alright, so now that we have our machine open, we can close this out. For today's room, we will be using a web app found under this IP. You can use the browser of your attack box to navigate it. You will see a page as shown below. So let's go ahead and copy this link. And here we can see the site. So everything is up and working. Let's review some key material regarding potential attacks on websites like this portal, specifically cross-site scripting or XSS. XSS is a web application vulnerability that lets attackers or evil bunnies inject malicious code, usually JavaScript, into input fields that reflect content viewed by other users. When an application doesn't properly validate or escape user input, that input can be interpreted as code rather than harmless text. This results in malicious code that can steal credentials, deface pages, or impersonate users. Depending on the result, there are various types of XSS. In today's task, we focus on reflected XSS and stored XSS. So reflected XSS, you see reflected variants when the injection is immediately prompted in a response. Imagine a toy search function in an online toy store. You search via this term. But imagine you send this to a friend who is looking for a gift for their nephew. Please don't do this. And this is what an scripted XSS payload would look like. There's a script inside of the link. If your friend clicks on the link, it will execute code instead. Impact: you should act, view information, or modify information that your friend or any user could do, view, or access. It's usually exploited via phishing to trick users into clicking a link with malicious code injected. Stored XSS attack occurs when malicious script is saved on the server and then loaded for every user who views the affected page. Unlike reflected XSS, which targets individual victims, stored XSS becomes a set and forget attack. Anyone who loads the page runs the attacker's script. To understand how this works, let's use an example of a simple blog where users can submit comments to get displayed below each post. This is a normal comment submission. The server stores this information and displays it whenever someone visits that blog post. And here is a malicious comment submission. So as we can see here, the comment is just a regular comment. And then as you can see here, there's a script added into the comment. Because the comment is saved in the database, every user who opened that blog post will automatically trigger the script. This lets attackers run the code as if they were the victim in order to perform malicious actions, such as stealing session cookies, triggering fake login pop-ups, and defacing the page. Protecting against XSS. Each service is different and require a well-thought-out, secure design and implementation plan, but key practices you can implement are disable dangerous rendering paths, make cookies inaccessible to JavaScript, sanitize input, output, and encode. To exploit XSS vulnerabilities, we need some type of input field to inject code. There is a search session. Let's start there. So here is the search terms, and here is a message to McSkitty, and then here are the system logs. So it wants us to start with previous messages. To exploit reflected XSS, we can use test payloads to check if the app runs the code injected. If you want to test more advanced payloads, there are cheat sheets online that you can use to craft them. For now, we'll pick the following payload. So let's go ahead and copy this. And it says reflected meow meow. So this site here would be considered vulnerable to reflected XSS. As we can see here, that gave us a flag. So we're going to copy this and go down to the bottom. Looks like it was the second flag. And this is going to be stored. So that's going to be stored. So the last question is going to be, what's the stored XSS flag? So let's scroll back up. Now that we've confirmed reflected XSS, let's investigate to see if it's susceptible to stored XSS. This vector must be different as it needs to be persisted. Looking at the website, we can see that you're able to send messages which are stored on the server for Mosquito to view later, navigate to the messaging form, and enter the malicious payload used before. And here we go, stored meow meow. Let's see, do we have another flag? We do have another flag here. And we can also see in the system logs, potential SSS detected in a message. So it does get logged when these attacks happen, but it's just as quick as whatever system admin can see that and take action on it. So we're going to take this flag that we just got from this. And there we go. Those are the basics to cross-site scripting, both reflected and stored on server side. If you enjoyed today's room, you might want to have a look at the intro to cross-site scripting room. That's a good room. I believe I completed that one a while ago. So we're going to go ahead and end this out. And we are done. This one was probably the quickest one out of all the events. And today is day, 11 or 12? I'm losing count at this point. But if you're watching this on YouTube, make sure you follow me on Twitter at rxsklife, and I will see you tomorrow for the next day. Thank you for watching, and I'll see you next time.